So I'm going to introduce now our next speaker, who is Elias Salem. Elias is from the National Veterinary School in Toulouse in France. He's currently doing his PhD, and he's going to talk to us about bovine respiratory pathogens in France, prevalence, and new virus discovery.
Hello. First, I want to thank the organizing committee for letting us presenting this work. It's about bovine respiratory pathogens in France, prevalence, and new virus discovering. So, a quick overview about the bovine respiratory disease known as the BRD. As it is known, it is the biggest problem in calf facilities around the world, with a multifactorial etiology consisting of a complex interaction between the environment, the host, and several pathogens. Now, in France, we can consider that the major pathogens involving in BRD are the bovine respiratory disease, the bovine respiratory syncytial virus, Manemia amylotica, and Mycoplasma bovis, in addition to all the other classical pathogens with difference in detection rates and pathogenesis according to the breeding facility and the system of breeding. So the objectives of our study was to do an exhaustive detection of the respiratory pathogens in breeding systems in France. Why is that? For three main reasons. First of all, we wanted to update our knowledge about the prevalence of different pathogens in the breeding facilities. Second, we wanted a clearer view about the co-infections in BRD. And third, based on several negative detection tests in the routine, we think that we might be dealing with new and unknown pathogens in respiratory disease. So for that, we have adopted two different molecular approaches for our strategy. The first one is the direct, specific targeted real-time PCR, and the second is the untargeted metagenomic sequencing known as the NGS. So the NGS is an exhaustive and unbiased detection technique that allows us to detect absolutely all the viruses present inside our samples and the unknown or undescribed viruses if they are present. And the direct real-time PCR is a tool that allows us to detect really the classical pathogens of our choice and also to confirm the presence of the unusual or new viruses detected with the NGS technique. So a quick view of our methodology that begin with the field sampling, passing by the purification of the sample and the extraction, the amplification of the genetic material inside it. We used the MySeq by Illumina technique in order to sequence in NGS our samples, passing by the bioinformatics work using several pipelines, and finishing by the target-specific research using real-time PCR. Concerning our samples, we have sampled two different regions in France, the Burgundy region and the southwest Midi-Pyrénées region. In Burgundy, we have sampled 134 samples of lung fragments, deep nasal swabs, transtracheal aspiration liquids, and in the southwest region, we had 160 samples of deep nasal swabs and bronchoalveolar lavage. All our sampled calves have respiratory disease, pneumonia, are 2 to 16 weeks of age, and we sampled them during the acute phase of the respiratory disease, and none of the calves had antibiotic treatment. So, as a quick summary of the result, surely you have detected the main and classical viruses of the BRD, so the bovine respiratory syncytial virus, the bovine parainfluenza virus, and the bovine coronavirus, with surprisingly a very high detection rate of the bovine coronavirus inside the lower respiratory tract, so in the bronchoalveolar lavage. We find this curious, very curious, because we already have always known the bovine coronavirus as a minor disease and initiator virus. So we raised the question of the role of bovine coronavirus in the BRD. This result was confirmed in NGS sequencing, where we have detected the bovine coronavirus in almost all of our samples, with a unique presence in 2 of the bronchoalveolar lavage. So we think that we might be reconsidering the role of the BCOV in the bovine respiratory disease complex. Another interesting result is the high rate of the co-infection. We have interesting high rate of co-infection in both lower and upper respiratory tract. So, about the NGS sequencing, we did a run that included 9 farms only, 9 pool of samples for the time being. We analyzed our data, our sequencing data of the run that we have done with the MySac technology. We used 2 different bioinformatics pipelines in order to analyze our sequences. We obtained around 12 million of sequences after filtration, bioinformatic filtration. And we have detected with NGS 4 additional viruses: the bovine rhinitis A and B, the bovine parvovirus type 2, and the bovine astrovirus. This bovine astrovirus is already known as having digestive and neurotropic tropism. In our case, we found it deep inside the lung in 1 pool of bile. And finally, we have detected the bovine influenza type D virus. So we focused on this bovine influenza type D virus, that is a influenza virus that was very recently detected in the United States, in pigs first and then in cattle. And using the genomic, also NGS sequencing and protein analysis, in addition to the absence of antibody cross-reaction with either of influenza A, B, or C viruses, there was a suggestion that this new virus must be classified as a new genus of influenza family. So that was the case, and it was known as, since then, as the influenza type D. The identification of this influenza virus in respiratory samples, in addition to the high bovine seroprevalence in the United States, suggested that cattle may be the main reservoir of this new viruses. So, using also our pool of samples, we have detected to go further and search for this new virus. In the Burgundy region, we found 6 positive samples, and in the southwest, we found 2 positive respiratory samples, having a total of roughly 4% of detection rate in France. That is in accordance with the USA, Italy, and China. So what about the pathogenicity of this influenza D virus? In the USA, the association with an upper respiratory disease was confirmed. Among our samples, 6 out of 8 positive samples have been associated with co-infecting agent pathogens, but 2 out of the 8 positive samples were only infected by influenza virus. So really, for the time being, we are not sure of the role of the influenza D virus in the bovine respiratory disease. We went further, and we have sequenced this virus using, and we have done, phylogenetic analysis of the French isolates. And here we can see that it clusters clearly among all the other influenza D virus detected in the world. And curiously, our French isolates clusters only lonely between the two groups, phylogenetic groups of the other isolates of the world. So to conclude, the discovery rate and genetic characterization of the new respiratory pathogens is growing rapidly nowadays due to the new developed molecular techniques. But the real importance and the reality of this virus remains in the field. So what about the pathogenicity of each virus? For that, which is really a big challenge, understanding the pathogenicity of every respiratory virus, especially when the virus is associated with a mild or moderate infection. As our current work is, we are doing a broader virome study to include all our respiratory samples, in addition to exploring the microbiome of the samples. So we want to go and search for the co-infecting bacteria in addition to the viruses. And we are preparing actually experimental infection of the influenza D virus to understand more its role. And thank you.
Thank you very much, Elias. So I'm sure we have some questions for him. Yes, I see a hand up there.
Yeah, Jansen again from the University of Calgary. Did you find the virus, influenza virus, in the respiratory lesions at postmortem?
Yes, we did. Actually, 5 of 8 positive samples were lung fragments. So they are lung fragments of pieces of lesions of postmortem calves. Yes, we confirmed the presence of the virus in the lower respiratory in the lungs.
Do we have any other questions? One more.
Stuart Carter, Liverpool. This may be semantics, but do you think you have enough information to call them pathogens?
Sorry?
Do you have enough information to call them pathogens? They might be commensals.
Sorry, I didn't get the question.
How do you know they're pathogenic?
How do you know that it is the influenza D virus that is causing the...
Actually, we are not sure. I'm not confirming that the influenza virus is a major respiratory pathogen. I hope it isn't, actually, but in order to confirm its role, we must go further and do... yes.
More studies, yeah. Okay.
Claude Hammers from France. It's something similar. The next generation sequencing is a very powerful tool. You will pick up thousands or millions of things, and for many of them, you don't know exactly what it is. And frequently, you will pick up things that are just commensals, and as long as you don't demonstrate the Koch postulate, you cannot say it's a pathogenic agent.
Using the NGS as a unique technique is not a good idea, actually, because you will detect absolutely everything that is present in your sample, and you don't have the biological evidence of the role, actually. For that, you have to do complete study from using the classical way, actually.
We have one last question here from Mark.
Hello, Mark Crawshaw. I may have missed it, but can you confirm whether you actually isolated the influenza virus in cell culture, or have you just found the genetic material?
Yes, we have isolated the influenza virus.
Right, okay, thank you.
Yes, we have French isolate.
Because I know that in the UK there was a lot of effort put into isolating influenza viruses at Weybridge, and they failed to do so. So that's a significant difference. Thank you.
Thank you very much.
Thank you.
So I'd like to